Hello everyone, myself Vinay Kumaram. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then please do subscribe to my channel. So in my previous videos, I was discussing about the fifth chapter of 9th standard mathematics that was on Introduction to Euclid's Geometry. So now in this particular video, we'll look into the exercise 5.1 questions which are there in this particular chapter. So coming into the first question in this exercise 5.1, here which of the following statements are true or false? So you have to basically tell which statements are true and which statements are false. And you should also give reasons for the answer what you give. That is why it is true or why it is false. So in this first question, you have 5 different questions. So in that, we'll look into the first question. Only one line can pass through a single point. So this is false because here we are not taking 2 points. We are only taking, so in the question you can see there is specifically they have mentioned single point. So that means there is no 2 points. If they have mentioned 2 points, then only one line can pass through 2 points. But they are asking single point. So that means one particular point will be there. And here they are saying that only one line can pass through this point. That is wrong. Multiple lines can pass through this point. So one line can pass like this, one line can pass like this, one line can pass like this, one can pass like this, one can pass like this. So infinitely many lines can pass through this particular single point. So that means here this particular statement is false. Now we will look into the second question. So here there are an infinite number of lines which pass through 2 distinct points. Here this is also false because if you have 2 distinct points, let's say there are 2 points A and B. So they are telling that infinitely many lines can pass through A and B. No, only straight line which can pass through A and B is this way. No other straight lines can pass through A and B. Either through A lines can pass, either through B lines can pass. But if you want to include both A and B points in a particular straight line, then only one line is only possible. This is according to axiom 5.1. So according to axiom 5.1, the statement is against that particular axiom. So that's why this is false. Now we will look into the third question. So in third question, a terminated line can be produced indefinitely on both the sides. This is true because if you have a line like this A and B, this line which has got terminated, it can be extended infinitely on both the ends like this. So that's why this particular statement is true. And postulate 2 supports this particular statement. So postulate 2 of Euclid's postulates, this particular terminated ends of a particular line can be extended indefinitely on both the ends. So now, and this for second question, you can give axiom 5.1 as the reference. Now we'll look into the fourth question in this particular first question. Here, if 2 circles are equal, then their radii are equal. So that means here 2 identical circles are there means their radius must be equal. So if you look into axiom 4 of Euclid's axioms, here if two things coincide with one another, then they're equal to each other. So here these 2 circles are already equal to each other. They have given in the statement. So that means they exactly coincide with each other. So these 2 circles exactly coincide with each other. So according to axiom 4, because these 2 circles are equal to each other, they coincide exactly with each other. So that means radius of these 2 circles will be equal. So radius of these 2 circles are equal. So here this particular fourth statement is true. Now we will look into the fifth statement. Here in the fifth question, they have asked that in figure 5.9, they have given one figure. So in figure 5.9, AB is equal to PQ, PQ is equal to XY, then AB is equal to XY. So here 3 lines are there. One is AB, the other line is PQ, and the third line is xy. Here they have given AB is equal to PQ and PQ is equal to XY. So here this can be written as AB is equal to PQ and XY is equal to PQ. So that means two different things, that is AB and XY, are equal to a particular common thing. So according to Euclid's axioms, AB should be equal to XY, and they have also mentioned the same thing, that is AB is equal to XY. Hence this particular fifth statement is also true. Now we will look into the second question in this exercise 5.1. Here you have to give a definition for each of the following terms. Are there any other terms need to be defined first? So if you want to explain one particular property in geometry, then you have to consider other property. In order to explain that property, you have to use another property. So there will be like bunch of definitions. So indefinitely it will just go on like that. So for example, if you want to define a square, then you have to define straight lines. If you want to define straight lines, then you have to define what is points. If you want to define points, then you have to define space. So there are so many things which you have to define in order to define one particular square. So that means here they are asking whether other terms is also required in order to define a particular term. That is, they have given 5 different terms here. One is parallel lines, perpendicular lines, line segment, radius of a circle, and square. So in order to define all these, you have to use another terms. So now first we will see the first question. So in first question they have asked you to define parallel lines. So parallel lines are the two straight lines which never meet anywhere, and there will be no single point common for two straight lines. So for example, if I draw two straight lines like this, then here AB is one straight line, PQ is another straight line, and here AB is parallel to PQ. So in order to define parallel lines, you can tell that there is no common point. There is no common point between two different lines. So that means here I have taken AB and PQ. There is no common point between AB and PQ. Or instead of giving examples, we can just generalize the statement. So that means here there is no common points between two distinct lines. So there is no common point between two distinct lines. Then those two lines are parallel to each other. So this statement is more than enough to define parallel lines. So that means two lines will be there and there will be no common points for those two lines. Then those two lines will be parallel to each other. So now we look into the second term in the same second question. Here perpendicular lines, you have to talk about perpendicular lines. So for perpendicular lines, 90-degree angle should be there between two straight lines. So whenever two straight lines are meeting with each other, those two straight lines should have 90-degree angle. So that means here also 90, 90, 90, 90. So that means 90-degree angle should be there between these two lines, these two straight lines. If these two straight lines are meeting at one common point and they are 90 and they are maintaining 90-degree angle, then these two lines can be known as perpendicular lines. This you can write in your own words. You can define in your own words. Now we look into the third question, that is line segment. So line segment is a particular straight line which is bounded between two terminating points, that is A and B. So for example, if there is a straight line like this and out of this straight line you're taking one particular element from this and you're naming the terminal points of this particular segment as A and B. So this acts as a line segment. So the line segment is a segment or a part of a straight line which is bounded by two endpoints. So line segment is part of a straight line. Line segment is a part of a straight line which has two terminating points or two endpoints. Now we look into the fourth term. Here you should define what you mean by radius of a circle. So radius of a circle is a line segment. Radius of a circle is line segment which is there between center of the circle to circumference of the circle. So if you are drawing a line segment from center of a particular circle to its circumference, so that line segment can be known as the radius of that circle. So in this question, you can clearly see you have to use another term that is line segment, and you should also use another term that is center and circumference of a particular circle. Because here they have also asked, do you require any other terms in order to explain the given terms? So now in order to explain this radius, you are taking help of line segment, center and circumference. Now line segment has different definition, center has different definition, circumference has different definition. And again, in order to give definition for line segment, you have to bring the straight line. And again, in order to explain what you mean by straight line, for straight line, you have to give another definition. So that means here, in order to explain each terms, you have to use other terms in order to explain that particular term. So here in this question, to explain radius, we are using line segment, center and circumference of a circle. So this is just one observation you can observe while writing definition for these terms. So now you have to define a square. So square is a quadrilateral. So square is a quadrilateral where all four sides are equal. All four sides are equal and all four interior angles, all four interior angles are also equal to each other. So this is the definition of square. So in order to explain square, you need to understand what you mean by quadrilateral. In order to understand quadrilateral, you need to understand straight lines, or you should understand what you mean by line segments. So that means in order to explain square, you require quadrilateral. In order to explain quadrilateral, you require sides and interior angles. And you also require the help of line segments. So that means you are using various other terms in order to explain one particular term, that is square. So these observations you can do in this particular second question. Now we look into the third question in this particular exercise. Here they have given two different postulates. That is, in first postulate, they have mentioned that A and B are the 2 points and C is in between A and B. So that means if you draw a straight line from A to B, C is there on this particular A and B line. So that means C is exactly in between A and B points. In the second postulate, they have mentioned that in the same straight line AB, so like if you're taking AB points and if you're drawing a straight line between A and B, then C can lie outside this particular straight line also. This is also possible and this is also possible. So that means these two postulates are consistent, but this is not very clear. So they have not clearly said whether this C is lying on the AB or this C is lying outside this particular AB line. So that means here there are so many undefined terms in these two postulates, but they are consistent because according to axioms you can tell that yes, A and B are the two different points and C is exactly in between A and B. So this C can lie on the straight line. There exist at least 3 points that are not on the same line. Here you can see A, B and C. If we are considering these 3 points are not on the same line. A and B are on the same line, but if you together, if you are considering A, B and C, here if C is outside, this particular postulate holds good. So that means here there is no proper clarity for this particular postulate. So there are so many undefined terms, but these two postulates are consistent with each other. Now we look into the fourth question. Here in fourth question, they are telling that explain this particular question using drawing. So you have to draw a figure and you should explain this question. So C is one point which lies between A and B points. So that means there is a particular straight line. So for example, AB is a straight line. So from point A to point B, there is a straight line. So C is the point which is lying in between A and B. And what they have given is AC is equal to BC. So here this AC is equal to this particular BC line segment. So using this, you have to prove that AC is equal to half AB. So AC is equal to half AB, you have to prove. So here in this question, we have three line segments. One is AB, another is AC, and another is BC. So in these three line segments, AC is equal to BC and C is in between A and B. So that means here AC plus BC. So here I am writing proof for this particular fourth question. Here AC plus BC is equal to AB because C is in between A and B. So that's why AC plus BC is equal to AB. Now here, since AC plus BC is equal to AB, here AC is also equal to BC. So AC is also equal to BC. So this you can take as equation 1 and this you can take as equation 2. So from equation 1, we can replace BC with AC. So that is AC plus AC is equal to AB because AC is equal to BC. Since AC is equal to BC, so whenever I write three dots like this, this represents since. So since AC is equal to BC, in the place of BC, I am writing AC. So that means I am getting here AC plus AC is equal to AB. Now 2 times AC is equal to AB. So if you bring 2 to RHS, it becomes 1 by 2. Or AB by 2, which is equal to 1 by 2 AB. So hence we have proved this. So that means here AC is equal to half AB. So in fifth question, if you have a straight line like this, that is from A to B, and there is one midpoint for this particular AB line segment. Here you have to prove that there will be only one midpoint for this particular line AB. So here you have to prove there will be only one midpoint for a particular line segment. So in order to prove that, we will consider two distinct points. So we'll consider C and D. Initially we'll consider C and D are two midpoints for this line segment. So initially we consider this as C and D as the two midpoints of AB. So we are considering this. Now since C is the midpoint of AB, so AC will be equal to BC, and here D is also midpoint. So here C is also midpoint and D is also midpoint. So that means here AD is also equal to BD. So that means here we are getting AC is equal to BC and we are also getting AD is equal to BD. So now since AC is equal to BC, AC plus BC will give you AB, and also AD is equal to BD. So here AD plus BD is also equal to AB. So here since AC is equal to BC, AC plus in the place of BC, I can write AC is equal to AB. So that means 2AC is equal to AB. So that means AC is equal to AB by 2. So this you call as equation 1. Now AD is equal to BD. So AD is equal to BD means here AD plus, in the place of writing BD, I'll write AD only, because AD is equal to BD, which is equal to AB. So that means 2AD is equal to AB. So AD is equal to AB by 2. So here, this we can call as equation 2. From equation 1 and equation 2, we are getting AD is equal to AB by 2, and also we are getting AC is equal to AB by 2. So that means here, therefore AD is equal to AC. So now we are getting AD is equal to AC. So this can happen only when D and C coincide with each other. So this can happen only when D and C coincide with each other. So therefore only one midpoint exists for a particular, only one midpoint exists for a particular line segment. Only one midpoint exists for a line segment. So this is what we have proved by taking all these examples. Coming to the sixth question, here you have one particular line segment which starts from A and ends at D. So in between you have 2 points, one is B and the other is C. So now in this question they are telling that AC is equal to BD. So here they have given that this particular AC is equal to this particular BD. Now we have to prove, AB is equal to CD. Now we have to prove that AB is equal to CD. So here what they have given is AC. So now we are doing proof of this. So here they have given AC is equal to BD. So AC is equal to BD is there. So AC can be written as AB plus BC, because B is in the center of A and C. So AC you can write as AB plus BC, which is equal to BD. Now this BD also you can write as, so AB plus BC is equal to BD also you can write as, here C is exactly in the center of B and D. So that's why BD you can write as BC plus CD. So that means here we are getting AB plus BC is equal to BC plus CD. So here BC you can bring to LHS. So when you bring plus BC to LHS, it becomes minus BC, which is equal to CD. So what is remaining is AB is equal to CD. So that means here whatever they are asking here to prove, we have proved that. That is AB is equal to CD. So coming into the seventh question, here y axiom phi. So here y axiom phi in Euclid's axioms is universal truth. Because so the axiom phi in Euclid's axioms is true for everyone in this world, and wherever in this world you go, the axiom holds good. So that's why it is known as universal truth. Axiom is true in the every part of word for every person. So that's why this axiom phi in Euclid's axioms is known as universal truth. So that's it. So this is just a simple explanation which you have to give for this particular seventh question. So this comes to an end for this fifth chapter in 9th standard mathematics, that was on introduction to Euclid's geometry. So from my next videos, I'll be teaching the 6th chapter of 9th standard mathematics. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.